Hello and welcome. Today we'll be looking at the center tapped full wave rectifier. We'll start with the design of the circuit. So a center tapped full wave rectifier employs a transformer with its secondary tapped at the center. The rectifier converts alternating current into direct current by employing two diodes. The diodes are connected to the opposite ends of the center tapped transformer, with the center tap considered as the zero voltage reference point. The center tapped transformer steps down the 240 volts AC supply into 12 volts AC, which is an RMS value having a peak value of 17 volts. The 17 volt AC power is then converted into 15 volts DC power. The 15 volt DC power must be converted into a pure DC power since the output of the diode rectifier is pulsating or it contains ripples. An inductive or a capacitive filter is then used to remove the ripples. A step-down voltage regulator is then used to regulate the DC voltage to 5 volts DC. So the components required to construct a full wave rectifier are as follows. The first one is the AC power supply at 240 volts. Then we have the center tapped transformer, which steps down the AC power supply to 12 volts. We have the two rectifying diodes that converts AC power to DC power. Then we have the filter components, which can either be an inductor or a capacitor. Then finally, we have the voltage regulator. So the performance parameters of the rectifier circuit are given in terms of calculations, with the first one being the peak current. Then we have the output current, the DC output voltage, the RMS current and voltage, rectification efficiency, ripple factor, form factor, and the transformer utilization factor. Next on is the operation of the circuit. So for the operation, a 240 volts AC input is applied to the primary windings of the transformer, which induces positive and negative signals on the center tapped transformer secondary. For the positive half cycle of the AC signal, one end of the secondary is positive with another end being negative, while the center point is at 0 voltage. The diode D1 becomes forward biased, while the diode D2 becomes reverse biased. The two diodes conduct alternately, with D1 conducting while D2 is not conducting, and vice versa. The current flows through diode D1, the load resistance, and the upper half of the secondary windings. During the negative half cycle, the polarities on the two ends of the transformer secondary are reversed. As a result, diode D2 is forward biased, while diode D1 is reverse biased. The current flows through the diode D2, the load resistor, and the lower half of the secondary winding. The flow of current gives the DC output voltage across the resistor. Then finally, we have the applications of the rectifier. So the first one, it is used in the conversion of AC power to low DC power. Then it is used as a power supply unit owing to its high efficiency. Then finally, it's used in powering of LEDs and motors. So that's the end of our session today. If you have any comments or questions, this is the forum. So goodbye and don't forget to subscribe. Thank you.